Hello and welcome. Photonics integrated circuits are set to enable the photonics revolution. These chips offer a unique combination of compactness, energy efficiency and cost, already benefiting the telecom market. However, as with many new technologies, lots of questions can be asked about their characterization. Hello and welcome again. I'm François Cougny, Product Line Manager at EXFO, with a particular interest in the PIC technology. And today I'll be presenting EXFO's solution for spectral testing of PIC. EXFO's just celebrated 35 years of helping customers with their optical fiber test requirements. Over the years, EXFO's portfolio expanded, starting with OTDR for optical fiber deployment and building up to today's proposition that covers testing needs from lab to live. Our products and services extend from development of new components in the laboratory to manufacturing, from installation to maintenance and validation, and even going further and providing live monitoring of the health of the network with troubleshooting tools. And as I said earlier, my interest is in PIC, so let's talk a little bit more about challenges our customers face when testing integrated photonics. Photonics integrated circuits are set to bring smaller, cheaper optical devices with lower energy consumption. Whether they rely on silicon, indium phosphide, or other substrates, testing these PICs is not as easy as other optical devices. Some challenges are linked to the measurement of the device and the test itself. Accuracy, repeatability, dynamic range are difficult to achieve for components with sharp spectral features. Ring resonators, for example, are particularly tricky to characterize correctly. When thinking about mass production of PIC, as is the case for PIC-based transceivers, for example, other challenges will arise, such as speed of measurement, integration into a simple setup, the ability to easily add new test functions in the future, and also gain full control of the equipment via automation. For some, these testing requirements are far into the future, and it could be easy to think that existing solutions will be good enough. We think these issues need to be addressed today. So the best time to test it is when the PIC is on the wafer. In that way, it's simpler to align optical and electronic probes to the component under test and then perform the required measurement. And these tests can be parametric, such as the spectral characteristics of the device, but it can also be functional. For example, the eye diagram when using a particular optical modulator designed to be integrated inside a transceiver. So coming back to spectral testing, it can require an optical spectrum analyzer if the device emits light, or as we call it, active component, or a component tester dedicated to measuring spectral features of passive components, components that guide, filter, or otherwise modify the light. When testing such passive components based on PIC, the best technique is the swept wavelength technique. The method uses a continuously sweepable laser to sweep the wavelengths and simultaneously record on the component tester the power going through the device under test. Every other parameter is monitored during the sweep. And because a single sweep takes a few seconds, it is a very fast method that provides picometer accuracy, a large dynamic range, and it's key for components with very sharp spectral features, as is the example here with a ring resonator of about 10 picometer width and very sharp spectral contrast. The additional advantage of the EXFO CTP10 component testing platform is the very large spectral coverage, the large port count, and the advanced measurement capabilities such as PDL. In the last 3 months, we have released 2 modules on the CTP10 that enable such insertion loss and PDL, polarization dependent loss, to be measured over an extended wavelength range by combining 3 lasers T100SHP, testing from 1240 nanometers to 1680 nanometers with 1 picometer resolution only take a few seconds. And the CTP10 provides a flexible and integrated solutions for such test conditions. As noted earlier, there could also be a need for parametric testing of active components such as lasers and amplifiers. That can be done using an OSA such as the OSA 20. And also it can pay to perform functional testing on components like modulators. And here again EXFO can provide solutions for bit error rate testing using the BA4000, or eye diagram measurement using the sampling scope EA4000. I hope that I have convinced you that the testing challenges can be overcome today with EXFO's portfolio of product. And if you want to discover more about this line of product, don't hesitate to visit our website or to contact me via LinkedIn. Thank you very much.